So for this one, it says give the domain of the function in interval and in set notation. Domain is just telling me what x values can be. So you are going to start back here at negative infinity. And then you're going to go along the x-axis. So you go from negative infinity, and your first problem here is right here at this hole. This hole is at -5, because remember we're talking about our x-axis. So -5. And then you're going to tell me, does it include it or does it not include it? It's always open parentheses here for infinity. There's a hole there, so it does not include that as well. All right? Your next step is to start at that point and to go to where you have your next problem. Your next problem's right here. You can see it up and down at -2. Again, -2 is not inclusive of that either. And then after that, you...
Hold on, what? You lost.
So -2 is right here. This is my next problem. See how it shoots off? It's an infinite discontinuity. See how it shoots off to infinity? So you have something at -2 that causes a problem. That's a non-remove. That's an infinite, right? Infinite. Versus removable, which is a hole. All right. They also want it in set notation. So set notation is this guy right here. And all you're going to do is just exclude those values that you just told me it did not have. And then tell me it can be any other real number, which is what that little piece means, element of the real numbers. So is it continuous? So if it is, just write continuous. If it's not, you're going to tell me what type of discontinuity. So in order to figure out if this first one is continuous, you want to see if the denominator causes any issues. If there was a square root, you would say, does the square root cause any issues? All right. If there's neither one of those, you may have a continuous function. All right. So we're going to factor this. Factors of 20 that add up to 9. Right. We want -4 and -5 because those multiply to give you 20. They add to give you -9. So where is this one 0? At x equals 4. And this one 0 at x equals 5. So that's where we're going to have discontinuities. Okay? At 4 and 5. So what type? Well... Look at this particular function. My numerator is x minus 5. My denominator factored is x minus 4, x minus 5. One of those is removable. Which one is removable? Yeah, so this guy, so at 5, at x equals 5, we have a removable discontinuity. Or a hole, right? Those are called holes. When we get into the next chapter, we'll talk about that, but removable. X minus 4 is not removable. I cannot cancel that with anything. So when it's not removable, it is infinite. When you cannot remove it in the denominator, it is an infinite. So back at that one we just had, you would just say, I have x equals 5, which is removable, x equals 4, which is infinite. The other type you may come across is a piecewise function. For a piecewise function, you're just checking where it changes here. Okay, you want to check there. Because x minus 2 is a line, that's an infinite function. So that's continuous. -2x minus 5 is also a line, that's continuous. What we really need to figure out is do they meet at the same spot so there's no break in the graph. And the way you figure that out is you plug it into both. So you plug it into the top one, 0 minus 2, well that's -2. You plug it into the bottom, -2 times 0 minus 5 is -5. No, they do not meet. That means this line ends at -2 on the y-axis, and this one jumps to -5 on the y-axis. And so it is discontinuous at x equals 0, and it jumps. So it is a jump discontinuity. This next one is, once again, give me the domain and set and interval notation. So in this case, you're doing the same thing you did with the graphs, except they didn't give you a picture. So you're going to have to combine what you did with the graphs and what you just did with the discontinuities to figure out what your domain is. And so you're really just figuring out, is there something that causes a problem? If I have a fraction, is there going to be a 0 in the denominator? If I have a square root, is there going to be a negative in the square root? That's really what you're trying to figure out. And so for this, you're going to factor it. We only care really about the denominator. It's not asking you to name what type of discontinuity, so we don't have to care if it cancels or not. Literally just your domain. So, factors of 2 that add up to 3. Yeah, 1 and 2. I only care where this is 0. So, if this is 0, I have a problem, so this cannot be 0. So what makes this first one 0? Well, -2 makes it 0, right? What makes this one 0? Well, -1. So that means x cannot be either one of those numbers or we have a problem. Okay, and that's your set theory. I mean, that's your set notation. Can't be those two numbers or we have a problem. And then interval notation, just go from -infinity to the first one to the second one, and that last one to positive infinity. So this is your big one that counts for really 4 points. You have discontinuities, you have x-intercepts, you have y-intercepts, and you have domain. Obviously, once you find points of discontinuity, that's going to help you with domain. And I don't care which way you write your domain. In your answer key, it basically writes it out in verbiage, all real numbers except for these. You can do interval, you can do set notation, whichever one you like for this, I don't care. For discontinuities, you want to factor. So factor everything because it's going to help you later. But factor the numerator and x comes out and we have x plus 3. Factor the denominator, I would actually take out a -4 and I have x plus 2. All right? For discontinuities, because you don't have to name them, you do not have to tell me what type, you really only care about the denominator. Okay? So for discontinuities, we're like, well, where is the denominator? 0. So this is discontinuous. At x equals -2. Because that denominator will be 0 at x equals -2. If I were you, I would go ahead and do the domain here. Once you have found your discontinuities, I would go ahead and do my domain. Because it's going to it's going to follow that. If you do it in set notation, it's going to look like this. If you do it in interval, it's going to look like this. All right, so whichever one you want to do is perfectly fine. And then we're going to get to our x and y intercepts.
Do we not have to say that it's...
All right, x and y intercepts. So for my x-intercept, I would do all my y equal to 0. So what does that mean? If my y is equal to 0, then that actually means my numerator is equal to 0. That's what that means. So when y is 0, that means your numerator is 0. And I've actually already factored my numerator here. So I'm just going to say, well, where does the x and the x plus 3 equal 0? Well, I set each of those equal to 0. I set this guy equal to 0. Well, that's going to happen there. And I set this guy equal to 0. Well, that's going to happen there. So my x-intercepts then are going to be at 0 and -3. 0 and -3. For y-intercepts, I plug in a 0. So I usually go back to my original one to do this. So for this is for, and I'll write it up here. So x-intercept, you set y equal to 0. For your y-intercept, you plug a 0 in for all x's. So I would go to the original equation and I would say, well, 0 squared plus 3 times 0 over -4 times 0 minus 8. On the top, I get 0 plus 0. On the bottom, I get -8. 0 divided by -8 is just 0. So my y-intercepts here would be at 0. And if you want to put them as points for your x-intercept, it's always where your y is 0. And for your y-intercept, it's always where your x is 0. So it says approximate points of relative extreme, then approximate open intervals where each function is increasing and decreasing. Once again, you are going from negative infinity to positive infinity on the x-axis. All right? So for the intervals, you're always going to start at negative infinity, unless for some reason you have like a square root function that doesn't start at negative infinity. But for this one, these continuous ones on the ends here, that's what it is. So negative infinity, and you're just walking along this x-axis, and you're looking for where it changes. Well, it changes right here. All right, so right here is my first change, and that is at -1. So -1. What's happening from this side up? Well, you're traveling up. Remember, think about it as though you're on a roller coaster. You're going up. So in this interval, you are increasing. And then from -1, we're going to track along until we get to our next change, and our next change is here at 0. Well, for that little bit, I was going down, so I was decreasing here. And then I truck along to my next one. My next one happens at +1. I am increasing. And then from 1 all the way to infinity, I am decreasing. So that's the first part of that. Your increasing and decreasing intervals is the first part of that. The next one are your max and mins. All right, so we have maximums. Well, these are maximums, those 2 points right there. So I need the actual point. So at -1, 5, and at +1, 5, I have a type of maximum, and then I need to tell what type of maximum. These are absolute. They're absolute because there is nothing on the graph higher. So these are absolute maximums, all right? And I then also have a minimum right here at 0, 4. I have a minimum, but stuff is lower than that. So this guy is going to be relative. Right, so I'll tell you how I check these. I check these by, did you give me the right picture of the graph? Did you give me a parabola? All right. And in that, is it facing up or down? So this was positive, so it was facing up. Then I look, did you move it to the right 3? Right? And then I look, did you move it up 3? Okay, so when I give partial credit on these, this is worth 1 point, but when I give partial credit, I look at the parent function, was that correct? Facing the right direction? And then did you move it left and right correctly? So this next one, you need to recognize what type of function this is, right? This guy is a square root function, all right? So I know that my parent function should look like this. So then what happened to it, okay? My parent function is right here, okay? He flipped. What's going to tell me it flipped? A negative in front. So I know it's going to be a negative in front. How did it move? Well, this guy moved right 3. Inside or outside, plus or minus? Yeah, inside and minus. So x minus 3 on the inside. And so that's what your parent function and your description should look like. So for this one, I have g minus f. That is literally 4x minus 4 minus 3x minus 3. Of course, there's a 1 in front of this, so we're good. Just leave it like that. But this is a -1. You have to distribute. -3x plus 3. And then you're just going to combine your like terms. 4 minus 3, that's 1x. -4 plus 3, that's -1. Okay. Biggest problem was just distributing the negative on that quiz. And composite, plug one in the other. So for composite, g of f means put f inside of g. So g of f is going to look like this. Instead of x squared, we're going to write 2x minus 2 squared plus 5. If you have something like this, you have to FOIL it. So you're going to get 4x squared minus 8x plus 4 plus 5. Because you have to FOIL this guy right here. And then just combine it to get your like terms. So 4x squared minus 8x plus 9.